Okay, hello. Today we are proving linear algebra section 2.3, invertibility and elementary matrices. Question 60 says, let A and B be n by n matrices such that both A and AB are invertible. Prove that B is invertible by writing it as the product of two invertible matrices. Okay, so we start off by saying what we're given. So let A and B be n by n matrices. So A and B are both square matrices. And we know that A and B are invertible. So that's also given. So we just say that as well. Now, we know that if A and B is invertible, which means when something is invertible, it means there exists a square matrix such that this time multiplied by it will give you the identity matrix. So we know that AB inverse times AB is the identity matrix. So from there, we can get this B and get the inverse of it on the other side. I think that's theorem 2.2 part A, but another way you could say this is theorem 2.2 in part B, where it says, oh no, wait. I think I used part B to say this, but then part A is if we have A, which is invertible, then A inverse is also invertible. And you can also say that the A inverse is equal to A. So that would basically be saying this right here becomes B inverse times A inverse. B inverse times A inverse times A times B is equal to the identity matrix. So from there, A inverse times A would just be the identity. And then we would have B inverse times B is the identity matrix. But I wasn't sure if I could say that because I knew that I had to write it as a product of two invertible matrices. So I didn't think that was the way to solve it. So I wrote it down like this because I think that's also equivalent. So yeah, so since AB inverse times A equals B inverse, thus B is invertible by product of the invertible matrices AB inverse and A, because they are both invertible matrices, and we know that multiplication of two invertible matrices is invertible. Yeah, that's it. That's the proof.